Generation and collection of gases. This video demonstrates how to collect gases with various methods. It includes upward delivery, downward delivery, displacement of water, and collecting gas with a gas syringe. Upward delivery. Upward delivery is commonly used for collecting gases that are less dense than air, such as hydrogen and ammonia. Firstly, the video demonstrates the generation and collection of hydrogen gas by upward delivery. The screen shows the apparatus and chemicals required for setting up the upward delivery. Add zinc metal into a clean conical flask. Then add dilute hydrochloric acid into the flask. Zinc reacts with the acid to generate hydrogen gas. Fit a rubber stopper attached with a glass delivery tube to the conical flask. Use a test tube to collect the gas. Fix it vertically and upside down with a clamp. At the beginning, the delivery tube and conical flask contain air, so the gas coming out is not pure hydrogen. Wait for a while and adjust the test tube to collect the gas. Collect the hydrogen gas generated from the reaction. Hydrogen gas is less dense than air, so it rises into the test tube. The air is displaced downwards. After a while, the test tube is filled with hydrogen gas. Stopper the test tube with a rubber stopper. Place the test tube appropriately. A burning splint can be used to test whether the generated gas is hydrogen. Ignite a splint and put it near the mouth of the test tube. If the gas is hydrogen, a slight explosion will occur and a pop sound will be produced. Now, the video demonstrates the collection of ammonia gas by upward delivery. The screen shows the chemical and the setup used for collecting ammonia by upward delivery. Ammonium chloride and calcium hydroxide are added into a test tube. Then, glass wool is put inside to avoid chemicals from spilling out during heating. Fit a rubber stopper attached with a glass delivery tube to the test tube. Connect the test tube to another one, which contains calcium oxide for drying the ammonia gas. The test tube is also fit by glass wool and a rubber stopper attached with a glass delivery tube. Insert the delivery tube into a test tube to collect the ammonia gas. Hold the test tube vertically upside down with a clamp. Heat the reactant mixture with a Bunsen burner to generate ammonia gas. Ammonia gas is less dense than air, so the ammonia gas rises in the test tube, and air is displaced downwards. After a while, the test tube is filled with ammonia. Fit a rubber stopper to the test tube. A moist red litmus paper can be used to test whether the gas is ammonia. Moisten a piece of red litmus paper. Put it near the opening of the test tube. If the gas is ammonia, the litmus paper turns blue. Downward delivery. Downward delivery is commonly used for collecting gases which are denser than air, such as carbon dioxide. This video demonstrates the collection of carbon dioxide by downward delivery. Here shows the apparatus and chemicals required for collecting carbon dioxide by downward delivery. Add marble chips into a clean conical flask. Then, add dilute hydrochloric acid into the flask. Marble chips react with the acid to give carbon dioxide. Fit a rubber stopper attached with a glass delivery tube to the conical flask. At the beginning, air is present in the delivery tube and conical flask, so the gas coming out is not pure carbon dioxide. Wait for a while and collect carbon dioxide with a test tube. Carbon dioxide is denser than air, so carbon dioxide sinks to the bottom of the test tube. Air is displaced upwards. When the test tube is filled up with carbon dioxide, use a rubber stopper to stopper the test tube. Place the test tube appropriately. Lime water can be used for testing whether the collected gas is carbon dioxide. Add lime water into the test tube. If the gas is carbon dioxide, lime water will change from colorless into a milky suspension. Displacement of water. Displacement of water is commonly used for collecting gases which are insoluble in water, such as oxygen. Now, we demonstrate the collection of oxygen by displacement of water. Here shows the apparatus and chemicals required for collecting oxygen. Immerse the test tube into water. Hold the test tube vertically and upside down with a clamp. Keep the mouth of the test tube in water to prevent air from entering into the tube. Add hydrogen peroxide into a clean conical flask. Then, add manganese dioxide into the flask. The decomposition of hydrogen peroxide produces oxygen gas. This reaction is catalyzed by manganese dioxide. a rubber stopper attached with a glass delivery tube to the conical flask. At the beginning, air is present in the delivery tube and conical flask, so the gas coming out is not pure oxygen. Wait for a while, and then put the glass delivery tube into the test tube to collect the oxygen gas. The generated oxygen passes through the delivery tube and goes into the test tube. The bubbles are oxygen gas. Oxygen displaces water out of the tube. So the test tube is filled with oxygen gas. After collection, fit a rubber stopper to the test tube. Place the test tube appropriately. Oxygen can be tested with a glowing splint. Put a glowing splint into the test tube. If the gas is oxygen, the splint will relight. Collecting gas with a gas syringe. Gas syringe can be used for collecting gases with any density. Here shows the collection of carbon dioxide with a gas syringe. Connect a delivery tube to a gas syringe. Add marble chips into a clean conical flask. Hold the flask firmly with an iron clamp. Add dilute hydrochloric acid into the flask. Marble chips react with the acid to give carbon dioxide. Fit a rubber stopper attached with a glass delivery tube to the conical flask. At the beginning, air is present in the delivery tube and conical flask, so the gas coming out is not pure carbon dioxide. Wait for a while and then connect the delivery tube to the gas syringe. Collect the carbon dioxide generated from the reaction. When the collection is finished, seal the opening of the gas syringe with a piece of paraffin